Hey everybody, it's Mike from TiALSport. Today we're going to go over static testing of external wastegates. We do publish very detailed instructions on how to do this on our website. I will put the link in the comments below. Ultimately though, what we're going to be doing is testing this wastegate for function. In doing so, we're going to provide you with a way not only to help troubleshoot any boost control issues, but also to make sure that anytime you change a spring or a diaphragm or service the wastegate in any way, you can confirm that it's working properly before you put it back on the car. What's going to be required for this test is obviously a wastegate. We have this wastegate set up with two of the optional lower ports blocked and the third port used just as a signal. The upper ports will vent to atmosphere. You will also need a regulated shop supply of air. You cannot use a hand vacuum pump or a hand pressure pump, and you're not likely going to be able to use a typical tire filling compressor. You need something with a tank, something that produces a significant volume of air as well as pressure. You want to regulate that at the tank to 60 psi, and you want to make sure that you don't use more than 30 psi to test the wastegate. These are values that are actually published in the instructions as well, and there's a reason why we call out for 30 psi as a maximum. We don't have a spring pack that goes higher than 24 psi, and there's really no reason to test it at a higher pressure than that. So when you have your regulator set up, this is our trusty regulator. We use this for multiple things, so I have multiple gauges attached to it. Today we're going to be paying attention to the 0 to 30 gauge. We have our shop air supply coming in, and we have an outlet that we're going to now connect to the wastegate and then clip it into place just to prevent any additional leakage. And what we're going to do is look for valve movement at and around the spring value that's installed. Now we installed a green spring into this MVR, which is going to produce about 3 pounds of boost pressure. And we're going to see a little bit of variance, which we can talk about later. But mostly what we're looking for is that this valve begins to open very close to what that spring rating is. So with that in mind, we're going to monitor this regulator. We're just going to bring air pressure up very slowly using the regulator. Most regulators work the same way. And we are now in motion, and we're right about 3 psi, which is pretty much what we expected. Now, cracking pressure to us is defined by 15 to 20 thousandths of an inch of travel. It's not easy to see that with your eye, so what I suggest is if you're in the field, just put your thumb or your finger on the valve. When you feel it move, that's essentially the cracking rate that you're seeing there. We do want to make sure we test this wastegate several times. Obviously it's fully open before 10 psi occurs because again it's a very soft spring. Closes right back up, works nice and smoothly, just the way you would expect it to. It is simply a pneumatic device with a valve attached to it. So we're seeing the travel that we need to see. Everything is working the way that we need to. This wastegate can go in place and we're going to see the kind of boost pressure that equates to the spring pack when we do that. The other thing that we're going to do too is by doing this static testing, we're going to show what you can expect to see when you're inputting this shop air with regard to air loss through the valve, stem, and guide clearance. We get asked quite often, is it normal for air to pass through that clearance? And the answer is yes, it is normal because we send air into the diaphragm chamber. The diaphragm chamber acts directly upon that spring and stem. And there's a clearance between that guide and the stem, and that clearance will allow air to pass through. Now, does it allow a lot of air to pass through? No. Is it engineered into the wastegate? Yes, it is. It is not a concern. So in this particular case, we're just going to simply open that wastegate valve again. And we're going to continue to add air, and you can begin to hear air escaping, and that air is coming from between the guide and stem. As I increase the pressure, the amount of air you hear obviously increases. We're not going to exceed 2 bar because we don't have to, but you can see where that air is coming through. It's simply escaping past that stem and guide. And again, this is not a functional issue. It's not a reason for you to be concerned about the control capability of the wastegate, and it certainly doesn't require any service. It's a brand new part. But we do want to demonstrate that so that when you are testing it and you do hear that air escaping past there, or you do feel it, or you do notice it as you bring the pressure up, especially if you have a stiffer spring pack, yes, you are going to hear some air move past. It's perfectly normal. You can feel it, you can hear it, and it will increase as you increase the amount of air pressure going into the wastegate. This is another reason why we do not recommend running more than 2 bar of air to the wastegate. If you continue to increase the air into the wastegate, you will have a correspondingly higher amount of air escaping past that valve guide and stem clearance. Again, keep it below 30, monitor the valve travel. If everything is working as it should and it's meeting that specification without any issue, that is a functional wastegate, and you can continue on with your installation. If you have any questions, of course, contact us at tech@TiALSport.com. And thank you.